Hello everybody, in this lecture I am going to solve a beautiful algebra problem, and the problem is already written on iPad. In this problem we are given m is a positive integer and mod of ax square plus bx plus c less or equals to 1 for all values of x belongs to closed interval minus 1 to 1. And m is the least upper bound of the function mod of 2ax plus b for all x belongs to closed interval minus 1 to 1, and we have to find out the value of m. Obviously m is the least upper bound because here we are given m is the upper bound and we have to find out the smallest possible value of m. Means we can say that the maximum value of mod of 2x plus b, or we can say that the least upper bound of the function mod 2x plus b over the given interval. Okay, fine, let's start. Let us suppose fx, quadratic function fx is ax square plus bx plus c. Okay, now I am going to find the constant a, b, c in terms of, because this function is given in the interval minus 1 to 1, so I am interested to find the value of a, b, c in terms of f minus 1, f of 0 and f of 1. F of minus 1 is what? A minus b plus c. F of 0 is clearly c. And what about f1? f1 is a plus b plus c. Therefore f0 is c. C is f0. Now with the value of c we can write a minus b is what? F minus 1 minus f0. And what is the value of a plus b from here? F1 minus f0. Okay, now if we add these two results, we get the value of a as a is what? Half times f1 plus half times f of minus 1 minus f0. Okay, and if we subtract these two results, we get the value of b. B is what? If we subtract these two results, second result minus first, then b is what? 2b. B is what? Half times f1 minus half times f of minus 1. Half times f1 minus half times f of minus 1. Okay, this is the value of b. Now what we have to do? We have to find out the maximum value of this expression mod of 2x plus b over the interval mod x less or equals to 1. Okay, let e equals to mod of 2ax plus b. Now I am going to put the value of a and b in this function. Since 2a is what? We can write 2a as what? 2a equals to f1 plus f of minus 1 minus 2 times f0. f1 plus f of minus 1, f1 plus f of minus 1 minus 2 f0 times x plus b. The value of b is what? Half times f1 minus half times f of minus 1. Okay, now if we collect the coefficient of f1 within this mod sign, then we can write x plus half times f of 1, and if we collect the coefficient of f of minus 1, we can write x minus half times f of minus 1 minus 2 f of 0 into x, something like that. Okay, since we have to maximize the expression, so I am going to use the triangle inequality here. We know that the triangle inequality is what? Mod of x plus y is always less or equals to mod of x plus mod of y. This result is known as triangle inequality, and I am going to use the triangle inequality on this mod function. Clearly the upper bound is mod of x plus half into f1 plus mod of x minus half into f of minus 1 plus mod of 2 f0 into x. We also know that the mod function is distributive in product sign. Mod of x plus y equals to mod x into mod y. This will implies e less or equals to mod of x plus half into mod of f1 plus mod of x minus half into mod of f minus 1 plus 2x 2 mod x into mod of f0 but we are given in the problem mod of fx less or equals to 1 for all values of x belonging to closed interval minus 1 to 1. Okay, now using this condition we can write mod of f1 less or equals to 1, mod of f minus 1 also less or equals to 1, and mod of f0 is also less or equals to 1. Finally, what we can write from here, e is less or equals to mod of x plus half plus mod of x minus half plus 2 times mod x. And since x is what, mod x is less or equals to 1, therefore this quantity cannot go beyond 2. And this sum represent what? This sum represent the distance of x, the sum of distance of x from 2 points minus half and half, and x varies from minus 1 to 1. So clearly the maximum value of this sum exists when x is at 1 or at minus 1, because sum of distance of 1 and minus 1 from minus half and half will be maximum, and its maximum value is what? Its maximum value is this one is half, and this amount is half, and this amount is 3 by 2. And on the other hand, if we take x equals to 1, then this amount is half and this amount is 3 by 2. That is, the sum cannot go beyond 2. Finally, what we have, e cannot go beyond 4. That is mod of 2ax plus b is less or equals to 4. Therefore, the smallest possible value of m is what? 4. Also there exists a quadratic function satisfying this result, or we can say that the equality exists if we suppose fx equals to 2x square minus 1. Then clearly what we take, a is 2, b is 0, c is minus 1. And also for this function 2x square minus 1, the graph of 2x square minus 1 is something like that. At x equals to 0, the value is minus 1, minimum value 0, minus 1, and the roots of this quadratic polynomial are 1 by root 2 and minus 1 by root 2. And at x equals to 1, the height of this function is obviously 1, and the function is even, therefore this point is also minus 1, 1. This is a graph of fx, and if we plot the graph of mod fx, then definitely the lower part, when the graph lies below the x-axis, that portion reflected with respect to x-axis, and the graph of mod fx is something like that. And the maximum point, this point, is 0, 1. So clearly for this quadratic function, mod of fx less or equals to 1 for all values of x belonging to closed interval minus 1 to 1. And if we are interested to find the maximum value of 2ax plus b in this case, then a is 2, b is 0, what we get? Mod of 4x, and x varies from minus 1 to 1, so this quantity cannot go beyond 4. Equality exists at x equals to plus 1 or minus 1. Hence proved. Thanks for watching.